Hi friends, today we are going to discuss about average speed and average velocity. Average speed. It is indicated by the letter V average. V average, it is equal to total path length traveled by the particle divided by time interval. Total path length traveled by the particle divided by time interval. That is, average speed is the ratio of total path length traveled by the particle to its time interval. Its SI unit is meter second inverse or meter per second. Path length meter, time interval second, that is meter per second, and it is a scalar quantity because path length is a scalar quantity. Therefore, average speed also a scalar quantity. That means it is having only magnitude. It is not having any direction. And average velocity. Average velocity. It is indicated by the letter V average bar. It is equal to displacement traveled by the particle divided by time interval. Displacement traveled by the particle divided by time interval. It is the ratio of displacement traveled by the particle to its time interval. Now, displacement, nothing but its unit is meter, time interval unit is second. Therefore, its SI unit is also meter per second or meter second inverse. It is a vector quantity. Because displacement is a vector, it is having, this average velocity is also having both magnitude and direction. That's why average velocity is a vector quantity. To calculate the average speed, it does not need the direction. But to calculate the average velocity, that we need both magnitude and direction. To indicate the speed of an object, we will not indicate the direction of that object, direction of motion of that object. But to indicate the velocity of the object, it should need the direction. That means we must specify the direction in order to indicate the velocity. Remember that. Here, the chapter is motion in a straight line. That is, the particles are moving along the same straight line. That means there is no change in the direction of motion of the particle when it is moving along the same straight line. In that situation, average velocity is equal to average speed. That is, a particle is moving along the same straight line. A particle is moving along the same straight line along the same straight line, we can say that magnitude of average velocity, magnitude of average velocity, I want to indicate the symbol in this manner. Magnitude of average velocity is equal to average speed. Magnitude of average velocity is equal to average speed when the particle is moving along the straight line. Remember that. Already we know that in the previous class it is path length traveled by the particle is always greater than or equal to displacement. Is always greater than or equal to displacement. In the last class we are observed some examples. By using those examples, we concluded that path length is greater than or equal to displacement. Similarly, here average speed nothing but path length divided by time interval. Velocity nothing but displacement divided by time interval. Therefore, we can say that average velocity, magnitude of average velocity is always less than or equal to, it is always less than or equal to average speed, less than or equal to average speed, because displacement is less than or equal to path length. Therefore, average velocity is less than or equal to average speed. Or, okay, with respect to this, average velocity is greater than or equal to average speed. Average speed is greater than or equal to average velocity. Sorry. Average speed is greater than or equal to average velocity. Now, in that last class, we have concluded that path length is always positive. Displacement may be positive, may be negative, may be equal to 0. Therefore, here average speed is always positive, but average velocity may be positive, may be negative, may be equal to 0. Remember that. Average speed is always positive. Always positive. But average velocity may be positive, may be positive, may be negative, may be equal to 0, may be equal to 0, may be equal to 0. Remember that. Similar to that of path length and displacement, average speed and average velocity. Now, here position time graph. I want to describe first position time graph. Position time graph. Okay, first here we will consider an object which is placed at this position, that is, you can assume it is the x-axis, positive x-axis, origin of positive x-axis. Its position is 1 meter initially. Okay, Here it is 2 meter, 3 meter, 4 meter, like this. When t is equal to 0 seconds, where the object is located, that is our stop clock switched on. When you switched on the stop clock, where the object is located, at the position 1 meter. T is equal to 1 second, object is located at the same place. T is equal to 2 seconds, object is located at the same place. T is equal to 3 seconds, the position of the object does not changes. Like that, after t is equal to 20 seconds also, the position of the object does not changes. That means, what is the state of this object? Rest. Object is at rest position. Here, this object is at the rest position. Now, we plot a graph in between position which is taken along the y-axis. I want to represent that position as x. Actually, it is the y-axis, but its symbol I want to consider it as x. Time t, it is along the x-axis. Time t, it is along the x-axis. Origin of two-dimensional coordinate system. Okay, 1, 2, 3, 4, 5, like that. Here also 1, 2, 3, 4, like this, 5. Position is in terms of meter, time is in terms of second. Now, for this situation, when we plot the graph, what type of the graph that we expect? It gives a straight line which is parallel to x-axis. It gives a straight line which is parallel to x-axis. Why? 0 seconds, position is 1 meter. 1 second, position is 1 meter. 2 seconds also, position is 1 meter. That means its position does not changes. Therefore, it gives a straight line which is passing through the origin. Sorry, it gives a straight line which is parallel to the time axis. I'm sorry. Next here, same position time graph. You can plot the graph in this manner. This is two-dimensional coordinate system. Origin of the two-dimensional coordinate system is O here. It is O, and it is time axis, time in terms of second. This is position. You can assume it as x in terms of meters. Now, here I want to plot a graph in this manner. A curve. We plot the graph in this manner. The graph is like this. It is a curve. Now, 1 second, 2 second, 3 second, 4, 5, and here it is 6. 2, 4, 6, 8, 10. These are in meters, these are in seconds. Now, when we plot the graph in between position time graph, time, it gives a curve in this manner. Okay, we want to calculate here, by using this graph, we want to calculate average speed or magnitude of average velocity during the time interval t is equal to 1 second to t is equal to 6 seconds. Average speed or average velocity. Average velocity or average speed we want to calculate. Average velocity or average speed during the time interval t is equal to 1 second to t is equal to 6 seconds. Because here the body is moving along the same straight line. When we plot the graph for that motion, it gives a curve. Thus, here magnitude of average velocity is equal to average speed that we want to calculate during this time interval. Now, average, V average or modulus of V average bar, whatever it may be, both are equal. It is equal to, now you can observe this. We will consider it as T1, 1 second as T1, 6 seconds as T2. Now you can draw a line in this manner here and similarly at here. This is the point P and correspondingly this point is Q. This point is Q. Now you can draw a line with respect to this point onto the y-axis, and similarly you can draw a line or a perpendicular from Q onto y-axis, from Q onto y-axis. Let us consider it as x2 and it is x1. Approximately this x1 is equal to 0.5 meters. x2 is equal to 10 meters. 10 meters. And t1 is equal to 1 seconds. t2 is equal to 6 seconds. Now what are the coordinates of p? X coordinate t1, y coordinate x1. Here q coordinates are t2 comma x2. t2 comma x2. Now average velocity or average speed. Okay, what is average speed? Path length traveled by the particle divided by time interval. What is the path length traveled by the particle during this time interval? Here to here. Therefore, what is about that path length? 10 meter minus 0.5 meters. That means x2 minus x1 divided by time interval t2 minus t1. Particle is moving along the same straight line. Therefore, path length can also be final position minus initial position. Nothing but it is the displacement. It is the displacement. Displacement traveled by the particle divided by time interval. Okay, that is 10 minus 0.5 divided by T2 minus T1, 6 minus 1, which is equal to 9.5 divided by 5. 5 ones, 9s, 1.9 meter per second. During this time interval, what is the average speed or magnitude of average velocity? 1.9 meter per second. Now you can join these 2 points P and Q with the help of a straight line. With the help of this straight line, we join these 2 points P and Q. Now what are the coordinates of P? T1, x1. Coordinates of Q are T2, x2. Now, it is a straight line. By using these 2 points, this straight line was constructed. Now, what is this x2 minus x1 divided by t2 minus t1 indicates? With respect to this straight line, this ratio x2 minus x1 divided by t2 minus t1 indicates change in y coordinates divided by change in x coordinates. Change in y coordinates divided by change in x coordinates with respect to this straight line. Therefore, this is called slope of the line PQ. It is called slope of the line PQ. Slope of the line PQ. Okay, in this graph, slope of the line PQ indicates average velocity or average speed. During this time interval, if you want to calculate average speed or average velocity, we can draw a line in this manner. Its slope indicates average velocity or average speed. Remember that. Okay, we will do another example. Okay. Now, during the time interval, t is equal to 2 seconds to t is equal to 5 seconds. We want to calculate average velocity or average speed. We want to calculate average velocity or average speed. Okay, here 2 seconds is to be taken as t1 dash and 5 seconds is taken as t2 dash. This point is taken as t2 dash. Now, corresponding to this t1 dash, you can draw a line onto that curve. And corresponding to t2 dash, you can draw a line onto the curve. Straight line. Now, this point is taken as p dash and this point is taken as q dash. Now, from p dash, you can draw a line onto position axis. Position axis. Let us assume this point as x1 dash. This point is x1. This point is taken as x1 dash. Corresponding to q dash, we can draw a line onto the position axis. Position axis. Okay. This point is taken as x2 dash. Therefore, what are the coordinates of t1 dash? t1 dash comma x1 dash. What are the coordinates of q dash? t2 dash comma x2 dash. Now you tell me, what is the average velocity or average speed when the graph is given in this manner? It is the slope of the line p dash q dash. That is, we want to calculate slope of the line. Slope of the line p dash q dash. Now you can draw a straight line corresponding to these 2 points. Corresponding to these 2 points, p dash and q dash. Now what is the slope of the line p dash q dash? Change in y coordinates x2 dash minus x1 dash divided by change in x coordinates t2 dash minus t1 dash. Now you observe this x2 dash minus x1 dash, final position minus initial position, or path length traveled by the particle. Change in x coordinates t2 dash minus t1 dash indicates time interval. Therefore, slope of this line p dash q dash represents average velocity or average speed. Now, here x2 dash minus x1 dash, 6 minus 1, you can assume x1 dash is equal to 1 meter. x1 is equal to 0.5 meter. This is x1 and it is x1 dash. Okay, x2 dash is how much? 6. 6 minus 1 divided by 5 minus 2, t2 dash minus t1 dash. That is 5 divided by 3 meter per second. 5 divided by 3 meter per second. Okay, now here the time interval is decreases. Initially the time interval is 1 second to 6 seconds. Now in this example the time interval becomes 2 seconds to 5 seconds. Initially it is 6 minus 1, 5 seconds. Now here it is 5 minus 2, only 3 seconds. If you decrease the time interval, what happens to the 2 points P and Q? Initially P and Q are exist here in the first example. In the second example, where it decreases the time interval, therefore Q reaches to this point, P reaches to this point. For our convenience, we are called it as P dash and it is Q dash. Whatever it may be, if the time interval is decreases, the points come close together. Those 2 points are approaches with each other. If you consider the time interval is only 1 second, that is t is equal to 3 seconds to t is equal to 4 seconds, this P dash Q dash, here Q reaches to this position, P reaches to this position, this is the straight line. Slope of that line indicates average speed or average velocity during this time interval t is equal to 3 seconds to t is equal to 4 seconds. That is, as the time interval is decreases, the points P and Q are approach with each other. Now, depending upon this, we will observe another concept. That is, if the time interval is decreases, the points P and Q are approaches with each other. If the time interval, I want to consider as the time interval, I want to take it as almost equal to 0. Almost equal to 0. That means t is equal to approximately 3.5 seconds to t is equal to 3.5000000001 second. That means what is the time interval? Very small. The time interval is very small. That is 0.0000001 second. The time interval is very small. Now when you are observed that time interval, what is the displacement covered by the particle? Or what is the path length covered by that particle during that small time interval? Does it covers the displacement or not? Yes, it covers the displacement, but the displacement is very small. It appears that it does not having any displacement or it does not covers any path length. Therefore, how you represent this time interval at here? It is not okay. It is very difficult to distinguish these 2 points on this line. That means it appears that both are coincides with each other. It appears that it is a single point. Now, similarly, corresponding to this point, or corresponding to these 2 points. Here, the 2 points are appears to us? No. Okay, corresponding to these 2 points, you can draw the two lines. This is one line and again another line. Now, when you join these 2 points on the curve, does the 2 points appears to us? No. Those 2 points are coincides with each other, almost coincides with each other. Therefore, when you join those 2 points and extend that line, it gives a straight line in this manner. It gives a straight line like this. Now you extend that line. You can extend that line in this manner. Now how it is appears to you? I want to take it as P double dash and it is Q double dash. What is this line P double dash Q double dash appears to you? How it is appears to you? It appears like a tangent to this curved path at this time. At this time, it appears like a tangent to this curved path. Tangent to the curved path. Remember that. Now, I will conclude the concept about this tangent. Okay. Okay, with respect to these two lines, what is the formula for the average speed or average velocity? Change in x coordinates divided by, change in y coordinates divided by change in x coordinates. Change in y coordinates, here it is delta x, x2 minus x1 or x2 dash minus x1 dash can be taken as delta x divided by time interval is to be taken as delta t, t2 minus t1. What is this delta x by delta t indicates? Change in y coordinates divided by change in x coordinates. Nothing but slope of the line PQ or slope of the line P dash Q dash. Now here, with respect to this line, we are assumed that the time interval is decreased. Time interval is almost equal to 0. If you decrease the time interval, what happens to these 2 points? These 2 points P and Q are approaches, and this straight line becomes the tangent to this curved path. That's why I am saying that here, if the time interval tends to 0, 0.00000000001 second, nothing but it tends to 0. If it tends to 0, then that velocity, average velocity or average speed can be named as instantaneous speed or instantaneous velocity. Then the instantaneous velocity of the particle or instantaneous speed of the particle. Instantaneous speed of the particle is V is equal to instantaneous velocity or instantaneous speed. V is equal to limit delta t tends to 0 delta x divided by delta t. We want to represent the instantaneous speed or instantaneous velocity with the help of this equation, because delta t almost equal to 0. Therefore, what about the delta x value? It is also very, very small. Therefore, this line becomes the tangent. Rv is equal to delta t tends to 0, delta x divided by delta t. In mathematics, instead of limit delta t tends to 0, delta x by delta t, we represent it as dx divided by dt. Dx, delta x nothing but change in position. Dx nothing but very small change in the position. Delta t, time interval, dt, very small time interval, nothing but delta t approaches to 0. Dx divided by dt. V is equal to dx divided by dt. Remember that. Now, what is this delta x by delta t or dx by dt? Change in y coordinates divided by change in x coordinates. Again it is change in y coordinates divided by change in x coordinates. Now, how to calculate change in y coordinates and change in x coordinates? Okay, listen to me. With respect to this line, I want to consider the coordinates of p double dash are, okay, you can assume it is t triple dash, okay, t double dash, I'm sorry, t double dash, it is x coordinate, and y coordinate is 0. Okay, you can assume it is x double dash. Now you can draw a line in this manner. You can draw a line in this manner. What is about this? 4.8 approximately. Now, you can draw a line like this. Okay, this 4.8 is taken as t, t1 double dash, it is t2 double dash, t2 double dash, and this is taken as x2 double dash. Therefore, coordinates of q double dash are t2 double dash comma x2 double dash, t2 double dash comma x2 double dash. Now you tell me, what is the slope of this p double dash and q double dash indicates? Slope of p double dash and q double dash indicates what it is? Tell me. I want to indicate this at here. Slope of the tangent p double dash q double dash is equal to how much? Change in y coordinates, x2 double dash minus x1 double dash divided by change in x coordinates, t2 double dash minus t1 double dash. What is that? Slope of p double dash q double dash. Here, for this line, that slope remains constant. It is a straight line. Okay, if you consider slope of this part is also same, slope of this part is also equal to the same, because it is a straight line. For the given straight line, slope remains constant. Therefore, with respect to this point, and this point, what is the slope? Which is also equal to P double dash Q double dash. That is, slope of this tangent indicates instantaneous velocity of the particle at the time t seconds. At this time interval, the speed of the particle or velocity of the particle we are called as instantaneous velocity or instantaneous speed. The speed of the particle at this time interval we are called as instantaneous speed. The velocity of the particle at that time we are called as instantaneous velocity. Now, how to calculate this instantaneous velocity? By using the same concept, it is slope of the tangent P dash or P double dash Q double dash. Nothing but slope of the tangent drawn to the given curve at the given instant of time. Remember that. Now, you tell me the definition for instantaneous speed. Definition for instantaneous speed. Okay, instantaneous speed, that is the speed of the particle at a particular instant. The speed of the particle, speed of a particle at a particular instant of time. At a particular instant. Or at a particular position. The speed of the particle at a particular instant or at a particular position we are called as instantaneous speed. Now, it can be calculated by using the mathematical formula limit delta t tends to 0, delta x divided by delta t, or v is equal to dx by dt. We will discuss about this dx by dt little later. That is, in the mathematics we are called it as differentiation of position with respect to time interval. We will discuss it is little later or in the next class. Okay, v is equal to dx by dt, or with the help of the graph, how we calculate the instantaneous speed? Slope of the tangent, slope of the tangent, slope of the tangent drawn to the given curve at particular instant of time. Slope of the tangent drawn to the given position time graph, drawn to the position time graph drawn to the position time graph at a particular time. At a particular time. That is, slope of this tangent indicates instantaneous speed. Remember that. Now, what is about the instantaneous velocity? Same. You can write down in the same manner. Instantaneous velocity. Instantaneous velocity. Tell me. Thus, velocity of a particle at a particular instant of time is called instantaneous velocity. Now, that instantaneous velocity, v is equal to limit delta t tends to 0, delta x divided by delta t. We are saying that it is velocity. That's why I want to put the bar on it. It is the displacement. Therefore, I want to put the bar on it. In case of motion in a straight line, is there is any difference between instantaneous velocity and instantaneous speed? No, there is no difference. There is no difference in between instantaneous speed and instantaneous velocity in case of motion in a straight line. V bar is equal to limit delta t tends to 0, delta x divided by delta t. Or it can be represented as dx divided by dt. It can be represented as dx by dt. We will observe this differentiation little later. That is differentiation of x with respect to time. According to the mathematics, it is differentiation of x with respect to time. Or with the graph, how we calculate it? It is slope of the tangent, drawn to the position time graph or position time curve at a given time interval or at a given point, at a given time. Slope of the tangent drawn to the position time curve at a given time indicates, its slope indicates instantaneous velocity, or its slope indicates instantaneous speed, because the particle is moving along the same straight line. Okay, I will give another example in order to explain this average velocity, average speed, instantaneous velocity, and instantaneous speed. We will observe that example in the next class. Thank you.